Hello and welcome back to Math Class with Mr. Kura. Today we're going to be talking about exponents some more, and we're going to be talking about the quotient rule. The quotient rule talks about when we are dividing exponents, when we have exponents that are being divided. So our example here is x to the fourth. We expand it out, is the same as x times x times x. And then divided by x to the third is like x times x times x. And the quotient rule tells us we can subtract those exponents, the numerator exponent minus the denominator, and we get x to the first. The reason that works is because we can cancel out or make giant ones with 3 of these x's. X divided by x is 1, x divided by x is 1, x divided by x is 1. So we're left with just a single x as our numerator, so x. On all these, when we're first starting especially, I really encourage you to expand these out and see what you come up with. So 5 to the fourth would be like 5 times 5 times 5 times 5. 5 multiplied together 4 times, divided by one single 5 on the bottom. Cancel out, and we're left with 5 cubed as our numerator, or just as our answer. We keep going to the next one. We get a 3. Our numerator is just a 3. Our bottom or denominator, there's 5 3s. 1, 2, 3, 4, 5. 5 3s. I can make a giant 1 here, cancel that out. That leaves me with 4 3s on my denominator. So 3 to the fourth. What do you think goes on top? We made this into a 1, so we're left with just 1 there. All right, 2 to the fourth. 2 times 2 times 2 times 2. All that divided by 2. We can cancel 1 out, and we're left with 3 2s on our numerator, or just 2 to the third. All right, let's go down here where we start to have some coefficients in front of the variables, and once again, just expand the whole thing out. So we get this is equal to 7. Let's scoot that up a little bit. 7 times k, 2 times 3, 7 times k times k times k. All that divided by 4 times k, k, k 3 times. Now, if we can simplify the numbers here, like if this was 8 over 4, we could simplify that. 7 over 4 we can't, so that's going to end up staying the same. Make our giant 1s, cancel those out. What are we left with on top? A 7 and a k, so 7k divided by just a 4 on the bottom denominator. All right, let's try a couple more. We'll skip over, I want to skip over to this one. So this is equal to 8 times m times m times m divided by 10 times m times m times m. So first of all, let's cancel all these m's out, and we're left with just 8 over 10. Now let's think about 8 over 10 in a different way. Let's think about, just like we expand m times m times m now, let's expand 8 to 2 times 2 times 2. 2 times 2 times 2 is equal to 8. And the denominator, let's expand that out to 2 times 5. 2 times 5 is 10. Now let's see what we can cancel. Cancel there. So we're left with 2 times 2, 4 fifths. And there were no m's left, so 4 fifths is that one. Okay, now that we did that, let's try that on this next one will expand the numbers out also. So we can expand 10 to 2 times 5, and then the p to 1, 2, 3, 4 p's. And then we can expand 6 to 2 times 3, and then times 1p. So what can we make giant ones out of? We can make giant ones out of this p. We can also make giant ones out of the 2, and we're left with 5 and then 3 p's, or p to the third, divided by 3. And we'll do one with different variables. So let's go down here to this one. Let's do the same thing we've done with the numbers, so we can expand the numbers out too. So this would be equal to 2 times 3. That's 12, right? 2 times 2 is 4. 4 times 3 is 12, times x, times 1, 2, 3 y's. Scoot that over a touch. On the bottom, I can expand that to, well, 4 times 4, and 4 times 4 can be 2 times 2. We can just put 2 times 2 times 4. 2 times 2 is 4. 4 times 4 is 16, times x times y. What can we cancel? 2's, x's, y's. So we're left with, on our numerator, we have 3y squared. On our denominator, we just have 4. So 3/4 y squared, or 3y squared over 4. All right, once again, thank you for spending some time in math class with Mr. Kura, and I look forward to talking to you again soon.